Okay, I would like everybody to go ahead and get their MIBs out. Get your MIBs out. Yes, Parker, if you don't have it, I'm going to show it to you. Was that your question, Parker?
Yeah.
Okay, yes, I'll be sharing it here as soon as I can move myself around here. I have not said what page yet. Put myself up there. All right. So today we're going to be doing the guided practice. Okay. And that is on page 408. 408. Told you this would. Told you this would kind of go quickly. Yes, ma'am. Or sir. I don't know who raised their hand.
Mr. Hall,
Yes.
since I don't have my mid, can I put it on my notebook?
Yeah, that's fine. That would be fine. Okay. So symmetry. Remind me again. What is symmetry? I want to call my good friend, my best friend, actually. When we were in kindergarten together, he used to share snacks with me. His mom had the best snacks. Sam.
A triangle that has.
No, what is symmetry? What does that mean?
I mean, it means a shape that is able to make the same exact shape when it folds together.
Good. When folded down a line of symmetry, it completely matches up.
Or it makes another shape, kind of like.
It could make another shape. It'd be smaller. Yeah.
Be like, as if you cut it.
Okay. So, which of the figures below has fewer lines of symmetry? And then they answer it for you. We talked about this on day one. And it doesn't seem like the rectangle and square would have a different amount of symmetry because they look very similar. But blue light came on, dude. That's as sharp as it's getting. But the square, you can go corner to corner, where the rectangle, you may not go corner to corner. So how they answer the question, and that's how you should answer the question if you were asked this question. All right? The square has lines of symmetry connecting the corners and pairs of opposite sides. The rectangle only has lines connecting opposite sides, not the opposite corner. Therefore, a square has more or has fewer lines than a rectangle. So the solution, rectangle. Okay? Question how the book answered that. Question how the book answered that one. Okay. 14. Name a kind of triangle that has a line of symmetry. Name another kind that does not have a line of symmetry. If you need to flip back in your book to remind yourself the names of triangles, remember there's an equilateral triangle where all the sides are equal. There's the isosceles triangle where two of the three sides are equal. There is the scalene triangle where none of the sides are equal. Then we have if we name a triangle by angle, we have an acute triangle, which means all the side angles are acute. We have an obtuse triangle, which means one of the angles on the inside is obtuse. We have a right triangle, which means one of the angle is a right angle. So think about it. What kind of triangle has a line of symmetry and another kind that does not? There's not one correct answer. Okay, there's multiple answers for this. Go ahead and flip back. I see Cohen doing that now. Looking back, you kind of see. If you have a question, well, then don't raise your hand. Write it out. It says show your work. That means draw a triangle and then draw the line of symmetry. Because you can say that a scalene has 15 lines of symmetry, but show me a scalene triangle that has 15 lines of symmetry. And I have an oceanfront lot in Indiana that I'll sell you.
What?
Because there's not a scalene triangle that has 15 lines of symmetry. There's not a single triangle that has 15 lines. But show me. That still would be one. But make sure to draw the one that does not have lines of symmetry. Make sure it does not have lines of symmetry. Okay. Give you a 30 more seconds. All right, I'm going to randomize it. Is Brianna on? Is she logged in from home?
No.
Okay.
No.
Okay. A lot of cats. Kenley.
No, she's not.
Okay, thank you. Kenley, what did you write down?
An isosceles triangle would have lines of symmetry, and a scalene triangle would not.
Okay, an isosceles triangle would have a line of symmetry, and a scalene would not. Do you agree with Kenley? Okay. Who's stomping over here? Bryson, what did you write?
Equilateral acute triangles and scalene acute triangle.
Okay. Or what? You just listed them.
Well, the equilateral acute has one and the scalene.
Equilateral acute triangle, guess what? Has 3.
Oh,
Has 3.
would it still count?
No, it says has a line, not at least a line. Has only one line of symmetry would be an acute, not acute. An isosceles triangle has one line of symmetry, and a scalene does not have any lines of symmetry. Yes, somebody raised their hand. Who raised their hand at home?
What does the line of symmetry mean again?
That is where you can draw a line. So, get my pencil out here. So if I am drawing on here what you should have drawn, if I have my isosceles triangle.
I still don't see how an acute equilateral has 3. I only can find 1.
Okay, we'll cover that. Hang on. So a line of symmetry is a line where you can fold it, and when it folds over, everything matches up. There's no overlapping angles or lines. Does that make sense?
Yeah.
Okay. Now, question that we had over here: how does an equilateral acute triangle? Okay, so because you could. I'm answering this for you, Gavin, and you're staring at your raisin box. Okay. I could put it from that tip.
That does not.
It does. It's the way that I drew it. It's not a real. So if we go out here, hang on, I have to move my head here. Gotta find and go back to the book, back when they talk about. Oh. They do not have an example of an equilateral triangle. Yeah, because that doesn't have an equilateral. All right. The next page they don't. But we take. Hang on a second. I am going to. So we'll come back to it and I will show you. I'm going to find the equilateral triangle. 412. Oh, that's okay. That would be. All right, 412. What scraps? Yep, right here. Yep. Okay. So here's our. Now I'm going to take a screenshot of this one. Okay. So if we take and go from point straight down, they would fold over on each other. Okay? If we go from here straight down, it would fold over.
I see that now.
If you go from here straight down. Again, this isn't going to be exact because with the measuring. But if you go from the point to the exact center point of the base of the triangle, it would fold over for an equilateral triangle.
It's basically just if you turn it over.
Yep, if you just keep switching it. It looks weird because without turning it over, but yes, that's how an equilateral triangle would. Okay, now go ahead, take a look at the next page. Oops. Draw all three lines of symmetry on the figure. How many lines of symmetry are there? Think it through. If you want to trace it and cut it out, or if you want to cut it out. Actually, do not cut it out. You may trace it and cut it out because we're going to be doing stuff on the back side later. Okay? Don't worry about looking at it. So just see if you can figure out what one they have. All right. I'm going to randomize this one. I really hope it lands on Emerson. But I'm thinking it's going to land on Finley. Or Mallory. Mallory, do you want to come up and draw the lines? Put it flat here. Nope, over here. I'll move it this way so you don't have to stare at yourself. There you go. It should. There you go. Okay, down the middle. All right. Is that one correct? Is that a line of symmetry?
Yeah.
Yes, it is. Did you find any more?
Yeah.
Okay, go ahead and mark your other one. Is that a line of symmetry? Did you find any more? Mallory did not find any more. Did anybody else find additional ones? Okay, Emerson, come on up.
I found two.
Do what
It's
you
hard
got.
to find out if one is it, but I can't do it on my right.
Okay, so you're going corner to corner. Is that what you have as well, Bryson?
Yeah.
Here we have some stones, some claps. This one's a little harder because we could not cut it out. Okay, we could not cut it out. But the corner to corner ones would not work. Same thing as a rectangle. When you fold them over, it would not. So if we trace it, all right, Robin's going to sit there. Here is the shape. Make it a little shorter. It goes. Cutting it out right now. Not perfect. For time crunch, it's doable. All right. So here's pretty much the shape. Okay. I can fold it down like that. Matches up. I can fold it in half like this. Matches up. If I go corner to corner, when you fold it, just like a rectangle, that's what you get. So it's hard to see it on here, but when you go from here, whoop, there we go, and fold it, this is sticking out of here, not matched up here. This is not matched up here, not matched up there. Okay, it's just like a rectangle. Just like a rectangle. That's why you can't go corner to corner on a rectangle. If that shape was a square cut like that, you could, but it's a rectangle. Okay? Yep, they'll have little corners sticking out. Let's take a look at number 16. Which figure shows the correct line of symmetry? And then answer whether or not Michael is correct. Or how he got that answer, I should say. Circle the one that is correct. Then explain why Michael, or how he got his answer. Just like Cohen, Michael. Decided it, but good, it's your middle name. Who said it was theirs too? Oh, it's Bruce as well.
It's koozies.
Koozies. Koozies is something you put over a can so you don't get like moisture on it. Don't get condensation.
Beer. I can't think.
What is the correct answer? What? So put that back over your mouth. You're like holding it down. Like, no, it wants to go up. I'm going to keep it on my chin. Over your nose. You didn't circle any, and you didn't write about Michael. What are you doing? Come on, put your marker away. You have no need to have your dry erase marker down.
Can you circle more than one kid?
There's one. There's one
This?
with the correct lines of symmetry. Yeah, no, a minute. Yes, ma'am. Well, I'm going to randomize it, so if you want to exercise your arm muscle, that's fine. All right. Audrey, it landed on you. First went to Alan, but he's not in here. So, Audrey, what did you select first?
I chose B.
So, Audrey chose B. Is Audrey correct? Yes, she is. B is the only one that is correct. What? Yeah, but B's the only one that has the correct lines of symmetry. Yes, Jocelyn.
Am I able to do the nice balloon?
Oh, sure. Sure. Tell us why Michael chose B.
Michael chose C because he thought that all the corners matched up, but he didn't trace and fold, so he got B as his answer.
Yeah. He thought corner to corner would work. But even without tracing and folding, how do you know that corner to corner will not work? What has to be the case in order for corner to corner to be symmetrical?
It has to be a square.
All sides have to be equal, yes. All sides need to be equal.
But isn't E all sides equal?
What?
Isn't that all sides equal?
Nope.
Just two of you and
Yep. All right. So, any question about what we did today? We will be taking our test tomorrow. Okay. But listen what I want you to do tonight. Tonight we have math practice and problem solving 425, 426. But also I want you to do the independent practice in your MIP. Okay?
practice and problem solving is 425.
Practice problem solving is 425, 426. Independent practice in your MIB on page 410, 411. For Parker and Peyton, did one of you raise your hand there?
I did.
Who's that?
Taco.
Okay, Parker. For you two, I will take screenshots of the independent practice so you can just write it down on a piece of paper, okay?
Okay.
All right. Somebody else has a question. Let me get to the.
I accidentally raised my hand.
It is 425, 426. Okay, no hands up. All right. So go ahead. Math practice and problem solving 425, 426, and the independent practice in your MIB. In your MIB. All right. That is your math homework tonight. And I will see you guys at 11:15? Yes, 11:15 for reading. All right. Bye, guys. Bye, Parker.